This content is brought to you by Mazunder Academy.
Hello everyone. Today we will start our discussion from Venn diagram. So my request to all the viewers, if you have not seen my earlier videos, please watch those videos because the concepts are related and it will be easy to understand the concepts of today's lecture if you have watched the previous videos. So let us start with Venn diagram. Venn diagram basically it's a pictorial representation, or you can say a visual representation of sets. A rectangle represents the universal set. Last lecture we studied what is universal set. So in Venn diagram, to represent universal set, we denote universal set by rectangle, and the sets will be denoted by circles, or sometimes it is oval shaped. Now these circles may be overlapping or may not, depends on if they have some common elements, then there will be some overlapping as shown in the picture, otherwise they will be disjoint sets. We will see this concept today. What are the disjoint sets, what are the intersections, union, these all. Next, let us see set operations. So first set operation is union of two sets. Suppose you have two sets A and B. If you want to find out their union, then as a symbolic representation of the definition, we write like this. This is the symbol union. So A union B is all those elements X such that X is in A or X is in B. So this is the definition of union. Now what it means? Union means all the elements which are common and uncommon in both the sets A and B. So they will be in union. So the Venn diagrammatic representation you can see here in the side it is shown. So A union B is that shaded region. So this region is the common region. So common as well as uncommon region all will be representing A union B. Now if I give an example, say for example A equal to this, B equal to this, and find A union B. So what will be A union B here? A union B is, what is the simplest way of writing? Write all the elements of A. 2, 3, 5, 7. Then check, is there any element in B which is already written here? Suppose 1. 1 is an element in B. Is it written already? No. So 1 will come. 3. 3 is already written here. So 3 will not write again. Then 5 already written. 5 will not write. 9 it will come here. Then 11 will come here. So this will represent A union B. Next concept is intersection. Intersection of two sets. Intersection means common. Suppose you have two sets A and B. A and B are two sets. If you want to find A intersection B, symbol is like this, intersection symbol, and the definition will be all those X such that X is in A and X is in B. Remember in union it was OR. and in intersection it is AND. AND means X must be in A as well as in B. That means only the common element between A and B will be available in their intersection. And the Venn diagrammatic representation, you can see intersection will represent only this common area. Only this common region will represent the intersection. Okay, so this is the common area, A intersection B. So as an example, if I give, say for example, A equal to 2, 3, 5, 7, 9, B equal to 3, 5, 9, 11, 13, and you have to find the intersection. Therefore, what will be A intersection B? A intersection B will be all those elements which are common. Suppose 2 is in A but 2 is not in B. Therefore, 2 will not come in intersection. 3 is in A and 3 also in B. Therefore, 3 will be there in the intersection. Similarly, 5 in both the places. Therefore, 5 will come in the intersection. Then 7 will not come. 9 will come because 9 is available in both A and B. And that will be the only intersection, because you see 11 is not available in both places, 13 is not available in both the places, both A and B. Therefore, A intersection B will have 3, 5 and 9. Now, this situation, if you want to represent in Venn diagram, then the representation will be like this. This adjacent figure you can see. This region represents the common area, that means intersection. So 3, 5 and 9 will be available in this region. Now the set A have few more elements, 2 and 7. So 2 and 7 will be outside the intersection but inside A. Similarly, if you go to B, this common 3, 5 and 9, and other than that 11 and 13 is there. So 11 and 13 will be inside B but not in the intersection. This region is the intersection. Okay, A intersection B. So this is the Venn diagrammatic representation of A intersection B, or you can say the set A and B. Now another example, just you can see, you can do it by yourself. If I just do say number 3, we need to find the intersection between phi and CDE. So what is common between them? Nothing, because phi doesn't have any element. Therefore, there doesn't have any common element. Therefore, their intersection will be phi. Nothing will be in intersection. Similarly, the other question you can check. Let's go to the next concept, that is disjoint set. So what is disjoint sets? Suppose A and B are two sets. A and B will be disjoint. A and B will be disjoint if A intersection B equal to phi. That means if A and B does not have any common element, then we say that both the sets A and B are disjoint sets, and their Venn diagrammatic representation will be like this: isolated A and B. There will be no common area. There will be no common region between A and B. So such representations are called disjoint set representation. Now I need to give an example. Say, identify pairs of disjoint sets from the following sets. So A equal to 1, 3, 4, B equal to 5, 6, 7, 8, C equal to all those X, such that x is a prime factor of 36. So what actually these elements will be if we write it as a roster notation? So prime factor of 36. So 2, obviously 2 is a factor of 36, 3 is a factor of 36, and 3 is a prime number. Then 4 is a factor, but 4 is not a prime number, so 4 will not come. Then next 6 is a factor, but 6 is not a prime number, so 6 will not come. Next 9 is a factor, but 9 is not a prime number. What else? 12 is a factor, but 12 is not a prime number. I think only this. So prime factorization, how to find? If you remember in school, I mean in previous classes we studied, if you remember how we find prime factorization. So 2, 18, then next again prime number 2, 9, then 3, then 3, then 3, 1. So what are the prime numbers, prime factors? 2 and 3. Okay, therefore the prime factorization of 36 is 2 multiply 2 multiply 3 multiply 3. So the prime factors only 2 and 3. Now let us check what are the disjoint sets. Suppose A and B. Do you have any elements common between A and B? No. 1, 3, 4, 5, 6, 7, 8, ... So A and B, there is no common element. Therefore A intersection B is phi. That is A and B are disjoint. Next, what about A and C? Look at A and C are not disjoint because 3 is common. So A intersection B is not equal to phi. So A and B are not disjoint sets. Now suppose A with D. So obviously A with D also there is no common element, therefore A and D are disjoints. Okay, A intersection D equal to phi, therefore A and D are disjoints. Okay, next come to B. B with C. B with C, there is no common element, therefore B with C, B intersection C equal to phi, therefore B and C are disjoint sets. Similarly, check B with D. B and D are not disjoint. B and D, B intersection D is not equal to phi. Therefore B and D are not disjoint. Okay, not disjoint sets. Next, C with D. C and D, they doesn't have any common element, so C intersection D equal to phi, therefore C and D are disjoint sets. Okay, so we understood what are the disjoint sets. Next concept is difference of sets. Now what is difference of sets? Difference of sets is denoted by this symbol minus. Okay, this is the symbol used for difference of sets. Now suppose two sets A and B. Suppose two sets A and B. If we want to find out the difference of B from A, that is A difference B, then what is the definition? All those x in A such that x not in B. All those x in A such that x not in B. That means what? Simply, what is the meaning of that? Simply, its answer will be remove all the common elements from A. Remove all the common elements between A and B from A. The remaining will be the A difference B. Similarly, you can write B difference A. It will be similar idea. All those say y in B such that y not in A. Another form in terms of difference, you can write A difference B in Venn diagram. A difference B means what? A difference A intersection B. That means their common elements you remove from A, that will be the difference between A and B. So in the Venn diagram, if we see this area is the A difference B. That means from A you remove the common part. This common part is removed from A, and that will be the result for A difference B. Let us take an example. Say, find the difference of A from B from the following pair of sets. So we will find the difference of A from B. That means we are finding B difference A. Understand? So if I answer 1, B difference A. So what will be the elements? What are the common elements in B and A? Do you have any common elements? Nothing. So it will remain B. 2, 6 and 8. That means it is nothing but B, because their intersection is 5. They doesn't have any common element. Next question, if I see, if we want to find B difference A, then do I have any common elements? Yes, B is a common element here. So from second set, that means from B set, you remove the common element, so it will be just Q. Similarly, if I answer third question, B difference A, remove their common elements, 1 common, 5 common, 9 common. Okay, so remove them. What will be the remaining? 2, 4 and 7. Similarly, if it is asked find A difference B, you can find the same way. Next idea is complement of a set. It is denoted by dash, or in some book you will find C, small c. So in this discussion we will use dash, okay, prime. So what is the definition of complement of a set? Suppose capital A is a set. If I want to define the complement A dash or A prime is all those x in U such that x is not in A. All those x in the universal set such that x is not in A. In another form of this representation of complement of a set is universal set minus the set A. That means the difference of A from U. Look at the diagram. If A is this pink color region, this is the set A, then A complement will be the region outside, which is inside the universal set, that the blue region. So simply we can say A complement is nothing but the whole universal set difference the set A. Let us take an example to understand it more clear. Say given universal set X belongs to N such that X less than or equal to 9. So basically your elements here, what are the elements? 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the elements in universal set. A equal to 1, 2, 7, B equal to 1, 6, 8, 9. So you need to find out A complement. So what will be A complement? A complement will be U minus A, U difference A. That means from U, remove all the elements of A. So A have 1, 2 and 7. So if you remove them, so what will be the answer? 3, 4, 5, 6, 8 and 9. So this will be the complement, A complement. Similarly, B complement, if you find, then what will be B complement? B complement will be U minus B. So remove 1, 6, 8 and 9 from U. So what will be the remaining answer? What will be the remaining elements? 2, 3, 4, 5, 7 only. So this is the idea about complement of a set. Remaining two questions you can check. What you will do? First you find A union B and then find their complement. Say let me do. First you find A union B. What will be A union B? A union B will be all common and uncommon between A and B. So it will be 1, 2, 7, 6, 8, 9. Therefore, A union B, its complement. Complement will be U difference A union B. That means from U, remove these all elements of A union B. So what will be remaining? 1, 2 removed. So 3 will be there. 4 will be there. 5 will be there. 6, 7, 8, 9 will be removed. So only this. Similarly, you can try D. So what you will do? First you find A complement, then find B complement and then find their intersection. So already I have A complement, B complement. So let me complete D. I need to find out A complement intersection B complement. So what will be the answer? In between A complement and B complement, intersection. Intersection means common. So 3 common. So 3 will come in the intersection. Then 4 common, 5 common, 4, 5. Then is there anything else common? No. Only 3, 4 and 5 common. Nothing else common between A complement and B complement. So this is the final answer. I hope it is clear to you how to calculate complement and intersection, union, this all. Next we have a very important law which is used a lot of times in different higher mathematics also. This is called De Morgan's law. What is De Morgan's law? It has two forms. One is using intersection, another one is using union. So let me explain it. De Morgan's law tells us if you have, say, A intersection B, and if you apply complement on them, then what will happen? Their individual complement between the sets and intersection complement will be union. So it will change. Intersection complement will become union, and exactly reverse the other one. If you have A union B, and if you apply complement, then it will be A complement intersection B complement. There is an example just to check whether it is correct or wrong. I will leave it to the readers, because we know how to find union, how to find intersection, how to find complement. So you just find left hand side. How to find left hand side? For this question, U is given, A is given, B is given. So first you find A intersection B, then you find A intersection B complement. Whatever the answer came, that is left hand side answer. Now go to the right hand side. First you find A complement, then you find B complement, and then finally you find the union between A complement and B complement. And you will see both will have the same final set. Left side and right side will have the same answer. Similarly, the question number 2. So I will leave it as an exercise for the readers. Next concept for us is application of sets. Now, application of sets, actually we have different applications, and mainly we find the cardinal number. Cardinal number, that is the number of elements in a set. So we apply this concept of set to find the number of elements that satisfying some condition. It is very easy to understand or calculate using Venn diagram. So Venn diagram also we have studied, but we will give you the formal definition or formal formula how to calculate the cardinal number for some sets satisfying some conditions. Okay, suppose I have two sets, A and B. Both are finite set, obviously they are finite sets. Then the first rule is number of elements in either A or B. What it means? It means number of elements in their union. Number of elements in their union, how to calculate? This is same as N A union B. Either A or B means nothing but it is union. So the first result is number of element in A union B. How to calculate? Number of elements in A plus number of elements in B minus number of elements in their intersection. So in Venn diagram, if I show you, then it will be more clear to you. Say for example, this is set A and that is set B, set A, set B. Now this portion is the intersection, A intersection B. Okay, A intersection B. Now if you want to find out this union means this all region, okay, this common and uncommon between A and B, this is union. So how can you calculate? The number of elements in this A plus number of elements in this B minus number of element in this region. Why this is minus? Because 2 times you have added this region, so 1 time you have to subtract here. When you have considered A, you have taken this region inside in your calculation. Again, when you have taken B, again this part you have taken in your calculation. So 2 times you have calculated, you have added this portion, so 1 time you have to subtract. So this is the formula which will be used a lot in set application. You must memorize this, you must save this. Second second formula is what? Only A. If you want to know how many elements in only A, sometime it will be written just only in A, not in B, may be written, may not be written. If it is written only in A, that means you will understand it is not in B, only inside A. In that case, you can see which region we are talking about. We are talking about this region, this green color region. We are talking about this region. This region is only in A, this region. So how to write this? You can see from whole A, you have to subtract the intersection. So basically, only in A means n of A difference B. And how to calculate? N of A minus n of A intersection B. So these rules we must remember, otherwise we cannot solve. Sometime maybe the question will be asked directly from Venn diagram. In that case, you need not to show the calculation, but if the question is given in terms of language or descriptive questions and marks more, in that case you must explain it, each and every part of your questions clearly, so that you will not lose any marks. Next is cardinality of neither in A nor in B. It is neither in A nor in B. That means in which region? It is not in A, not in B. That means the region will be outside here, outside of their union. Understand? Neither A nor B means it will be outside their union. That means A union B complement this outside region, this region will be neither A nor B. So basically it will be what? Cardinality of, in two forms you can write using De Morgan's law, A complement intersection B complement, or you can write cardinality of A union B complement. That means outside their union. How to calculate it? The number of elements in the universal set minus number of elements in their union. Okay, the last one is only in one of them. Only in one of them. What it means actually? It means your diagram is, suppose your diagram is like this. So what it means, only in one of them, that means I want only this person, only in A and only in B. Okay, so basically we want to find the number of element in A difference B union B difference A. A difference B union B difference A. And how to calculate it? Only in one of them. So it is number of element in A plus number of elements in B, and then minus 2 times number of elements in their intersection, because this intersection part will be added 2 times, once with A and once with B, and we don't want at all. Therefore we will subtract 2 times this intersection. So with this we can start our applications. So let's take an example of application and then we will go to the exercise. See, in a class there are 40 students. 22 play badminton, 11 play both badminton and table tennis, 16 play neither badminton nor table tennis. How many play table tennis but not badminton? So it is always suggested that Venn diagram question, you draw the Venn diagram so that it will be easy to you to visualize the situation. So this is U, and there are two sets. There are two sets, 22, suppose badminton I will denote by B and table tennis I will denote by T. Now, in a class with 40 students, number of elements in the universal set, that is 40. Then 22 play badminton. So, number of students play badminton is 22. 11 plays both badminton and table tennis. That means number of students plays badminton and table tennis both. Both means intersection. This is 11. And 16 play neither badminton nor table tennis. That means outside the union. Understand? That means number of students B union T, they are complements. B union T complements. That is equal to how many? 16. So look at here, 16 students here outside B union T. And again, total U is 40. So using difference rule, I can find out what is B union T. So I can write, therefore, number of students who played badminton or table tennis, that is union, will be equal to number of students in the union minus number of students in B union T complements. So this will be equal to 40 minus 16, and that is equal to 24. So 24 students playing both, I mean some of them playing. So 24 students playing badminton, table tennis, and some of them playing both. Okay. Now what we have to find out? How many play table tennis but not badminton? How many find table tennis but not badminton? So we need to find out this portion. How many play table tennis? We need to find this area. That means we need to calculate number of students in T difference B intersection T, or you can say number of students only table tennis. This we need to calculate. Now we don't have this value of n of T, I mean number of student who is playing table tennis. This value we don't have. So we have to calculate this using the union formula. What is the union formula? Already we have number of student B union T equal to n of B plus n of T minus n of B intersection T. Now this calculation n union, now we have B union T, its value 24. Just now we have calculated. So this will implies 24 equal to number of student playing badminton is how many badminton? 22, and intersection 11. Okay, 22 plus n of T minus 11. So from here, if we side change, we will get n of T equal to 24 minus 11. 24 minus 11 is 13. Therefore, we need to calculate n of only t. Only t means n of t minus n of b intersection t. That means 13 minus 11, and that will be equal to 2. Therefore, only 2 students playing only tennis, not badminton. That is my final answer. Next, we will see if there are 3 sets A, B and C. Obviously all are finite sets. Then the formula or the relationship will little bit change. How the formula will change? Let me show you. The formula will be something like this. N cardinality of A union B union C. Before it was 2 sets, now it is 3 sets. So how it will move? Individual cardinality n of A plus n of B plus n of C. These all plus. Then minus n of A intersection B minus n of B intersection C minus n of C intersection A, or you can write A intersection C. Then plus n of A intersection B intersection C. All 3 intersections. So this is the way we write the formula when it is 3 sets. First 3 will be plus, then all 3 will be minus, then the third component will be plus. And there is a question here in the example. Okay, so this rule we will use in the exercise, and for the time being we are skipping these examples. The readers, you can see these answers after watching my next lecture, because the video is becoming long, so I will stop here. This rule I will use, this formula I will use in the exercise directly. We have similar type of questions like with 3 sets in the exercise, so I will solve there itself. And this question we have answer in the book, so in the textbook you can follow and you can understand after seeing my next part of the lecture. Thank you very much for listening me. See you in my next video lecture.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.